Hello everyone, and welcome to our next lesson here on exponentials and their properties, exponential functions and their properties, I should say. We're going to look at a bit of modeling and then also some simplification in this lesson too. It's kind of like a potpourri or mixed bag of topics. So we're going to kind of skip this introductory lesson that, again, you might see here. Hopefully you should have your unbounded student version of the lesson in front of you here. We're going to skip this opening exercise. You're welcome to try it out for yourself, okay? It's something you can save maybe for your teacher and stuff like that to do. It's just going to be hard for me to show paper folding here on this video and stuff like that. Okay, but we will examine this folding right here, where we have a table that displays the thickness and area of a folded square sheet of gold foil. In 2001, Brittany Gallivan, a California high school junior, successfully folded this size sheet of gold foil in half 12 times to earn extra credit in her mathematics class. Rewrite each of the table entries as a multiple of the power of 2. So if you look here, right, if you start with a sheet of gold foil here, they measured the thickness of that piece of gold foil. Think of it just like aluminum foil, right? So it's like a, that metal kind of stuff we use to like cover things. But in this case, it's not aluminum that it's made from gold, just like flattened out gold. Okay, and so this is the thickness of that gold sheet of foil. And so that's our starting amount. There is no folds where she starts. Now, if she folds it in half once, that's going to double the thickness, right? Because you're doubling up the amount. So you can see it's that originally that 0.28 just to times it 2. Okay, folding it in half one more time, so now it's 2 total folds, is going to double again. So it's going to be, again, that 0.28 times now 2 2's, right? Times a 2 here, but then times another 2 here to yield 2 to the second. And so on and so forth. We're going to keep multiplying by an additional 2 in each step, which will result in higher powers of 2 from our original situation here. Okay? On the other hand, if you think about the area, the surface area, okay, of the kind of top layer of the gold foil, it starts with 100 square inches, but then when she folds it in half, the top layer will now only be 50 square inches, halving it again, 25, and so on and so forth. So in here, we're multiplying by 1/2. Okay, or instead of multiplying by 1/2, we know from our exponent property it's the same as times 2 to the negative 1. And again, times 1/2 here, same thing as times 2 to the negative 1. So then, starting with 100, right, we're just going to keep adding by additional powers of negative powers, I should say, of 2. Okay? And so that's just a little exercise there and seeing where exponents can come up with folding, pieces of paper and stuff like that, how you can, model that with exponents. Here's some of the simplification stuff that I told you about here. So I'm going to pause the video here and we'll get into this in the next video.